reaction, I might just right off the bat see burning CH4, complete and balance my reaction, find my heat of reaction. And that's a fine place to start. If I do that, I might then feel stuck because I don't know where to go from there. Looking back at the question, actually let's start there. So CH4 burning. Burning means add O2, make CO2 and H2O. Since this is a combustion reaction, the water we make will be a gas. C's are balanced. I need a 2 there to balance my hydrogens and a 2 there to balance my oxygens. Finding heat of reaction. Products, so CO2 plus 2 times the value of water as a gas. Make sure you picked the right value off the chart. Minus reactant, CH4 is negative 74.8. So, negative 393.5 plus 2 times negative 241.8. This simplifies to be negative 877.1 minus negative 74.8. My heat of reaction is negative 802.3. So from here, habit tells you go into a proportion. I'd have nothing to put on the right-hand side. I don't know how much heat I need in this specific case. I don't know how many moles of CH4 I'm burning. So instead, I'm going to go back to the question, revisit it, and I realize that when I have the grams of water and the change in temperature of water, that's enough to do a Q equals. Now, consider if it's one step or multi-step. I can tell just from looking at this, it doesn't pass through 0 or 100. There are no phase changes. It's just a one-step problem. If you want to draw your graph to see that it's one step, that works too and doesn't take long. So for the water, Q equals mass of water, Cp of water, delta T of water. Plugging that in, I get 710,600 kilojoules, or, just because that's a big number, sorry, that was in joules. Just because that was a big number and I'm going to need it in kilojoules anyways, 710.6 kilojoules that were absorbed by the water. The reason I know the water is absorbing heat, its temperature went up. If the water is absorbing that much heat, in this case of me burning some specific mass of methane, that same amount of heat must be released by burning the methane, or by the reaction. So, 802.3 kilojoules is if I use exactly 1 mole of methane. Obviously, I didn't use exactly 1 mole of methane because I only need 710.6 kilojoules. I can solve for the moles of methane then by cross multiplying. I get 0.886 moles of methane. Grams equals moles times molecular weight of methane, or 14.17 grams.